Alright, hello everyone. My name is Nicholas, and today I will be talking to you about smell-inspired machine learning systems. So I'll begin by showing you a car. Fascinating? Probably not. The thing is, every year in Australia they cause a lot of problems. Tens of thousands of hospitalizations, billions of dollars of loss to the economy, and the list goes on. Right, so clearly we have to find a solution, and I want you to think broadly of one. Just as a hint, think back to my introduction. Now, if you're thinking of machine learning, or ML for short, then congrats, that's my focus for today. Now, as the name kind of suggests, that's when computers are able to learn. And in the context of cars, that means they can learn to avoid accidents. Which sounds great, and we've seen such technologies begin to popularize already, with things like self-driving cars and autonomous traffic networks. It gets pretty cool. Unfortunately, we've also seen that they're not perfect, and sometimes they can lead themselves into accidents. So we can do better than this. But in order to do so, we have to know where the problem lies. And that's in the way current machine learning systems are designed. They're actually inspired by the way our brains process vision. So what happens is an object is detected by sensors, and through this kind of top-down approach, that image gets put together. It's a bit like a puzzle. And in the end, that final object can be precisely identified. And that's what the system uses to avoid it. Now that sounds great, but it's too focused on precision. You see, you think about how a toddler knows the precise difference between a pen and a pencil. You'd have to train them, right? Show them first, and let them know which is which. The thing is, cars can run into billions of things, and you can't reasonably train them to recognize everything. That would take too long and be too expensive. And so if a car is unfortunate enough to be approaching something it's never seen before, well, it won't know what it's looking at, it won't know what to do, and that means it won't know how to prevent the accident. So research teams from around the world have been effectively trying to redesign machine learning, and they took to a different sense smell for inspiration. And now through an almost opposite bottom-up approach, that object gets broken down even further. And in the end, what's detected are patterns of the object. Now that's great because it provides that sought-after versatility, not just for cars, but for things like medical diagnosis and even space rovers. So that means that it's you think back to the child example, they're able to look at a mechanical pencil and probably tell you what it does. It writes. And that's enough precision. So with less training, we're able to reap the benefits of ML. In fact, a team at Columbia University, found that with just samples of 100, they were able to get their system working. So that's a huge improvement. Of course, this technology is not perfect. Firstly, it really does lack precision. And so where that is required, smell-based ML may not be the way to go. Furthermore, it's very new. And so while teams behind this design are very hopeful of its benefits, only time will tell exactly how it can be used and how well it does. I, for one, am very hopeful of smell-inspired ML's benefits. So, if I were to ask you, how can we reduce car-related casualties? How can we prevent nearly 60,000 hospitalizations, 1,000 deaths, $30 billion of loss to the Australian economy every year? Well, I hope we can now agree that we should let smell inspire ML. Thank you.